So Matt's gonna be like a tough act to follow. I'm gonna introduce myself. I'm gonna talk about what Transmute is, what we're doing, kind of the problem, and then I'm gonna show you how we're using Lerna to solve that problem. And then I'm gonna show you a little bit about Lerna, and then I'm gonna show you it all running. So let's get started. Yeah, it's on. It's definitely on. Sad. I can MC it if we want. Yeah. Give me this thing. Give me that mic. All right. There we go. You guys can hear me in the back? Awesome. So I'm Orie Steele. I'm CTO at Transmute. And this talk is going to be about our monorepo and how we use monorepos to build complicated, decentralized Ethereum software. So what is Transmute? Transmute's a decentralized app engine for enterprise development teams. It's under development, and the stuff I'm going to show you today it's rough and it's in progress, and please save your hate for later. If you really feel the urge, we co-host the Austin Ethereum meetup, which is also on meetup.com. So if you're interested in Ethereum and you want to learn more, Matt's often there as well from Grid Plus. So feel free to come to the Austin Ethereum meetup if you want to learn more about Ethereum. This talk is going to be about Lerna and monorepos. Sorry, I'm learning how to hold this. And so one other thing to note is, like at Transmute, like Matt, I have a feeling we feel the same way. We take a sort of DevOps first approach. We care a lot about continuous integration and deployment. And in particular, the thing that we're trying to do is make decentralized app development more portable and easier sort of across local, on-prem, and public cloud environments. So again, this is talk about our monorepo. We've already heard the definition of a monorepo, but I'm going to put it here anyway. The monorepo is a single repository holding code for multiple projects, which are not always related. So we've kind of been over this already, but there's basically three core value props of the monorepo. The simplified organization, easier to get a dev environment up and running. It's definitely like the #1 most valuable part of it. It encourages modularization by reducing the cost of it. So without things like Lerna or Meta, it's a lot of overhead to manage multiple modules, multiple repos, feature branches across them, integration tests, that kind of thing. And so simplified dependencies is kind of just restating that. Again, I needed 3 things on my slide. So you can easily update one dependency and make sure that you haven't broken anything that depended on that anywhere else. And then the final point is just, these features together help you track the health of your complicated collection of projects from one place, one set of code coverage, integration tests, and that's going to help you with PR velocity. You have features spanning multiple dependencies, that kind of thing. All right, so at this point, I'm going to dive into showing some repos, and I'm going to talk briefly about how Lerna works before I show you how we're using it. Get out of here. Can't get to my thing. Matt's had this slide up for a while, so I figure I'll leave it up for a while too. Who here is familiar with NPM? Yeah, that's right. Every hand. All right, so you all know about node modules. You all know about package.json. What Lerna does is it basically creates a folder structure in your Git repo that exploits the npm link command. And what that lets you do is it lets you have the package dependencies in some graph, and Lerna will automatically link built versions of those packages. So when you are testing your new feature that changes 3 dependencies that are used in 4 different packages, some of which depend on each other, what Lerna is going to do is it's going to look at the version number of each of those package.jsons for each of those dependencies. It's going to look at all all of them, and then it's going to link the ones that are built with the changes, and it's going to be as if you had published the new version and you had npm installed. And so the basics of Lerna is the first thing that you're going to do is you're going to do lerna init, and that's going to initialize a Lerna repo. And the key feature that you're going to see is you're going to see a packages directory here, and you probably will also get a lerna.json file. Ours looks like this. And so the main point here is that all your packages are going to go in this directory. So the next thing that's going to happen is you're probably going to want to install and build dependencies. And so when you want to run a normal npm command, you do npm run build, npm run start. With Lerna, you can scope the command to a specific repo. So the question in the back, about doing that for meta, the way that you do that with Lerna is just use the scope attribute. And I can show you how we're doing that here in our giant mono repo. So first thing I'll note before I get kind of just going to go through all of this as it comes to me. We have a command line tool that helps deploy and configure services inside of Kubernetes. So like Ethereum test clients, decentralized storage providers like IPFS. So our command line tool is written in Node.js, and it kind of wraps Ansible, and it talks to network services. And so every time we build a new version of our platform, oftentimes we'll be updating our command line tool as part of those new set of features. So in this case, what our continuous integration tests do is we use that command line tool to set up a cluster, and we install Ganache, which is a test version of Ethereum. We install IPFS, we install an API gateway, and we configure them automatically with this command line tool here. And then you can see we're running npmi and lerna bootstrap. What lerna bootstrap is doing is it's linking all of these package dependencies that I was just talking about. So we go back here. You can see we've got like a bunch of different package dependencies, and similar to Matt's example, we have these adapters. This is like when you start to see these kinds of things, you should be thinking about a mono repo or a meta repo, because it's like the same kind of flavor of thing. They're dependencies of some of these other libraries. You're probably gonna like make changes to a bunch of them when you realize that you've done something terrible in the original interface. So when you see stuff like this, maybe think about mono repos. In this case, these two guys are a dependency of this guy, and this guy has this guy as a dependency. This guy has these guys as a dependency. This thing sort of is used to set up all the infrastructure that we use to test all of them. So you can see there's like a tangled mess that we're dealing with, and that's why we chose to use Lerna. So when Lerna Bootstrap runs, it's just installing all of the dependencies for those packages I just had on the screen. And then what we've chosen to do is like we want to run our tests in a specific order. So we just use the scope command to call out the tests that we want to run in the order in which we want to run them. So in this case, like we want to test this decentralized identity library first. So we just scope it, we call it, and it runs. And when its tests are passed, we go on to the next one. We want to test the adapter next. And we're going to test our another adapter. And finally, we're going to get bound through testing of some smart contracts with the Transmute framework of Truffle. And what these smart contracts are testing is actually, they're testing a connection to Ethereum and IPFS running inside of minikube that was installed and configured and managed by that CLI. So this test is actually an integration test on that CLI tool that we had. And when we make changes, those changes change the services that are installed inside of Kubernetes. We want to make sure that any library that was depending on those services is still working. Like maybe there was version drift, or maybe there's something weird that's happening and the RPC interface has changed, and we're all going to be super sad if we don't test the full integration of everything. Yep. And so, then at the end of this, we get code coverage, and we report the code coverage to code coverage server. And so basically what happens is, if we have a particularly awesome pull request that happens to touch a lot of these packages, we'll get integration tests across all the different pieces that were touched. We'll get a code coverage report on the pieces that we're choosing to report to code coverage, which can be from each of the different packages. And then we can review that pull request. We can see, yep, all the tests passed. This is great. And the code coverage was good. And we have confidence that, you know, the overall integration of this new feature isn't going to totally brick our system. Yep. So then the only, like, the last thing to show you is that, like, obviously, like, we're still heavily under development. We've got, like, lots of failing builds. And when things fail, we can take a look at them. We can see, like, what's going on. And this one here, you can see there's a bunch of lerna errors around, like, you know, a specific requirement. So as we're making feature changes, having this Travis CI system really helps us keep sane as we update package dependencies across all these different systems. I'm going to show the Travis YAML file because this seems like over there, it seems like super sad because it's like, you know, really long and complicated, but this Travis YAML file is actually super short. Like, it's 50 lines, and it's testing an integration of Kubernetes and Ethereum and a custom JavaScript framework with a whole tree and graph of package dependencies. And this 50-line Travis YAML file with lerna tests all of them working together. So, like I said, like, you know, we chose to scope them out. There's other ways that you can do this. It's just that we have an opinion on the order in which we want to test things, and I'd rather it just fail and end as soon as possible so I can fix it. I think the total build time for this is like around 15 minutes, which is pretty long, and that's mostly because of the Kubernetes dependencies and, like, the CLI thing that's spinning up those services. So you want your builds to fail. As soon as they're going to fail, you want to go fix that problem. I don't want to wait for the report, the rest of that stuff. So that's pretty much it. I can talk a little bit more about lerna if people have questions about it. Yeah, thanks. Go. Yeah, you can ask me about IPFS. Go. Yeah. 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 No, it's good. It's a good question. So I love IPFS. It's really awesome, super cool. I'm sure it's why you're using it as well. It has a number of features that are alpha. The whole thing is alpha. It says it's alpha. It says it's alpha, and yet there's still, like, huge ICOs and Ethereum projects built on top of it. It says very clearly it's alpha software. It feels very much like alpha software. You know, they're pretty upfront about that. The specific features you're talking about, like IPFS pub sub, and for those who don't know what IPFS is a content addressed file system that's super fucking awesome. And Cloudflare actually recently released a gateway for it. So if you search Cloudflare plus IPFS, you can read a lot more about it, and you'll see why Cloudflare thinks it's awesome. It's for the same reason I think it's awesome. It's because content addressing is the future, and should have been the way that so many things should have been built. And some things actually are built that way. But the main point that you had about, like, pub sub. Yeah. So in order to use the IPFS version that supports that WebRTC relay, you have to, like, turn on the experimental flag and connect to, like, a relay server that's going to connect everybody. And that the best, my recommendation is, with everything for IPFS, like, run your own infrastructure that you're in control of, that you can reboot. Don't like use Infura. I mean, maybe use Infura, but you should run your own infrastructure, especially for IPFS, as you're developing stuff. Yeah, yeah. So lerna is just a wrapper around npm commands, and so assuming that your npm RC is good and that your token wasn't stolen from that ESLint hack a couple weeks ago, your private npm like repos will work just the same way, and the packages should all get installed properly. Like what lerna is doing is what Meta is doing, but only for JavaScript. So if you're running a polyglot framework with like hardware devs and C and a bunch of other stuff, like maybe lerna isn't right for you. Our approach was just to take all those other packages and make them JavaScript packages because we love JavaScript developers. Yeah. So one point I will make about lerna is like the package versions that you have in there. There's two kinds of ways that you can manage versioning in a monorepo. You can have one version across everything, and oh, shouldn't do that with my hand. You have one version across everything, and you can also have like separate versions across each of them. We do the second approach, and we like often will like increment only one version and npm publish. If you go to npm install a package that you have been using lerna bootstrap with the npm link feature to do work on, the package won't actually potentially exist, and so you'll have trouble running npm install for those cases. So that's like a common thing that happens with people who are building stuff with lerna, is that they forget to publish their packages and they just start incrementing version numbers, and at some point you do need to publish to npm if you want to be able to run npm install. PM hygiene is not good. But what he's saying is correct. Actually, a lot of these packages haven't been published because they're still under development. So that's another thing that's kind of cool about lerna, is like on both sides. Like one, those packages can all become public npm packages, and two, as you're building them, they don't have to be. So there's a bunch of them that haven't been published yet. And in order to use them, you have to like be in the mono repo deving on our stuff, which is under development and needs to be cleaned up. Yeah. That's a super good question. So the question is like, at what point do you decide to start breaking packages out and like modularizing everything? And I think the whole like microservice debate here is like super relevant. I love microservices. I love cloud functions. If you start your project by building them, you're going to pay a lot for managing that overhead. And so I actually think the best way to do things, until you're like super used to Meta or Lerna and you can just do it without thinking about it, I would think it's best to build a monolithic app first, get to the first sort of feature stability that you like, and then split the modules out based on where you tend to spend the most amount of time making just changes to that one part. Like that's a thing that could be a separate package, but I'm a big fan of monolith first and microservice second. Yep, go. So it's kind of gnarly, and the main reason is that like Travis is running in a virtual machine. So with Kubernetes, like normally you would run in Linux, we run VM driver none. So it's just regular Docker Kubernetes for minikube. But you could use VirtualBox, but you can't in Travis because it's already inside of a VM. And so we are testing each of those services installed from our CLI using Ansible and Helm, installing Kubernetes services in Minikube, and then we're connecting those frameworks and libraries and apps to Minikube and testing everything against that. Yeah, so I was at Google Cloud, and that's totally what they told me I should be doing. And I agree. It's just this is super easy and free, and that's the only, like, you could be using yeah, KOps, or there's a bunch of other services for CI/CD and Kubernetes. Like there's one that's just like on the tip of my mind. I can't remember. It's not Brigade. It's, oh, see, there's a lot of them. But like, you know, the issue with all of them, like red, green, like green, blue, whatever the colors are, deployments, like you have to have that cluster up. You're burning money to keep that thing up just to do QA. This costs nothing because all these are public. If it were private, it would cost a little bit, but we're not, at a certain point, like if we were having like tons of commit velocity, this wouldn't make sense at all. Like we're not going fast enough to really feel the pain yet. And not yet, but they will. And when they do, we will do exactly what you're saying. We'll have a QA cluster, but we'll still run these kinds of integration tests deploying against it. It'll actually be better because Minikube isn't really much of a QA environment. Yeah, so Lerna and Yarn are probably not super good friends. Maybe they work together. Every time I've tried to get them to play together, they don't really work well. So I'm kind of like, I was of the Yarn camp, and then I found Lerna, and then now I'm just of the NPM like camp. I don't use Yarn anymore. I don't know how it affects this. I do know that you know, in Travis, node module caching, like all the rest of that stuff still applies as it normally would. But I can't answer the question about Yarn with this. I know that there's issues about Yarn and Lerna that I come across when I have errors, but I usually just don't use Yarn, and then Lerna works. It's kind of, yeah, I would just stick to NPM if you're using Lerna. Cool. Thanks, guys.